All right, let's dive right in. We are surrounded by these incredibly powerful AI agents, right? But there's a huge problem hiding in plain sight. They're all working in their own little bubbles, completely unable to talk to each other. So in this explainer, we're going to break down the journey from these isolated agents to what could be a true symphony of AI collaboration.
And look, this isn't just some abstract, theoretical problem. This quote from a developer on Reddit just nails the real-world frustration. How do you even get one AI agent to intelligently pick the right tools for a job, let alone get multiple agents from completely different companies to work together on something complex? It's a massive hurdle, and it's one we have to clear. So, here's our game plan for today. We'll kick things off with what we're calling the lonely agent problem. Then we'll explore the shared language they need to communicate. After that, we'll dissect the anatomy of a communication protocol, look at the frameworks that actually connect them, check out the push for a universal standard, and finally wrap up with why this whole thing matters so much.
Okay, first up, the lonely agent problem. We have these amazingly capable AIs, but at their core, they're fundamentally disconnected from one another. Think of it like this. You've got an expert in finance, an expert in logistics, and an expert in marketing. Each one is a total genius in their own right, but they're all locked in separate rooms, working in these isolated silos. They can't team up on a big project, which just torpedoes their collective potential. Well, that's pretty much the state of most AI agents today.
So how do we fix this? How do we break down those walls? Well, the answer is actually pretty simple in concept, but really complex in execution. We need to create a shared language, a lingua franca for all AI agents to speak.
And that brings us to the key idea here, the Agent Communication Language, or ACL. Now, the easiest way to think about an ACL is that it's made of 4 essential parts. You've got the language itself, the grammar, the verbs, and a shared dictionary. We're about to break each one down, but the crucial point is this. An ACL is a complete system that allows agents to not just talk, but to actually coordinate complex actions together.
So, if an ACL is the language, what's a protocol? Well, a protocol is the grammar. It lays down the law. It defines how a message should be structured, what counts as a valid response, and, importantly, what to do when communication breaks down. It's the rule book that keeps the conversation from turning into chaos.
And within that grammar, we have performatives. You can just think of these as the verbs of the language. A performative tells the other agent the intent of the message. Is it a request for action? Is it just trying to inform you of a new fact? Or is it flagging an error? This is absolutely critical for understanding the purpose, not just the words.
Finally, every language needs a shared dictionary, right? In this world, that's the ontology. It's a controlled vocabulary that makes sure when one agent says customer, another agent understands it means customer, not client or user. This prevents those killer misunderstandings, and it's what allows, say, a sales agent to work seamlessly with a shipping agent.
Now, there are kind of 2 main ways to do this. You've got the classic ontology-based approach. This requires all the agents to agree on that shared dictionary from the very beginning. It's very structured, very rigid. Then you have the newer, generative AI-based approach, which is way more flexible. It basically uses a powerful AI as a universal translator, letting agents with different internal dictionaries understand each other on the fly.
Okay, enough theory. Let's get practical and actually look at the blueprint for an agent conversation. What does it really take to build one of these protocols from the ground up? Well, it really boils down to 4 key steps. First, you've got to define the roles. Who's the planner? Who's the researcher? Who's the doer? Second, you choose your verbs, your performatives, based on what you need them to do. Third, you design the message structure itself, the digital envelope and what goes inside. And finally, you map out the common conversation flows, like a simple back-and-forth request and response.
So let's peek inside that digital envelope. Just like a physical letter, a digital message needs all this metadata to get where it's going and to be understood. It needs a unique ID for the message and the whole conversation, a sender and receiver, a timestamp, and that performative we just talked about. All of this stuff wraps around the actual content. This isn't just boring paperwork, it's the critical routing info that makes the whole system actually work.
And here's what that looks like in practice. A planner agent packages a request into a message for a researcher agent. Inside, the content would be crystal clear, spelling out the task, like task market_scan, and the query competitors for new AI headphones. See? This is no longer abstract. It's a concrete, actionable instruction being passed from one AI to another.
So we have the blueprint for a protocol, but how do developers actually build these connections?
especially between agents from totally different vendors or systems. That's where frameworks and middleware come in. They are the essential toolbox for integration.
The most important tool in that box is middleware. Think of it as the ultimate diplomat and universal translator. It's this software layer that sits between the agents and just handles all the messy, complicated parts of communication so the agents themselves don't have to.
This table breaks down its 3 critical jobs. First, it's a postal service, handling message routing to make sure every message gets to the right agent. Second, it's a protocol handler, translating between different communication standards. And maybe, most importantly, it's a semantic translator, making sure the meaning of the message isn't lost in translation. This is the magic layer that lets agents built by completely different teams on different platforms finally cooperate. A framework like LangGraph is where the rubber really meets the road. It allows a developer to take agents built with completely different toolkits, say one from Microsoft's AutoGen and another from Crew AI, and then weave them together into one single seamless workflow. This directly solves that developer's problem from the start of our explainer. It provides the connective tissue to build these complex, multi-vendor workflows.
Okay, these frameworks are fantastic, but they lead to an even bigger question. What if everyone could just agree on one single universal standard for how agents talk to each other?
And that's exactly what's happening. Google, along with over 50 major partners like Salesforce, SAP, and LangChain, are all working together on an open standard called the Agent-to-Agent Protocol, or A2A. The sheer scale of this collaboration tells you this is a huge industry shift, and their goal is incredibly ambitious: to create the HTTP for AI agents, a fundamental, universal protocol for the entire agentic web.
The design principles for A2A really show how practical this whole effort is. I mean, they aren't trying to reinvent the wheel. It's built on familiar web standards like HTTP and JSON. It's designed to be secure enough for enterprise use from day one. It can handle long-running asynchronous tasks, and it's built to handle anything: text, audio, video, you name it.
We've gone from the problem to the protocols to the global standards. So let's bring it all home and talk about the real-world impact. Why does turning these silos into a symphony actually matter?
Because this isn't science fiction, it's already delivering real-world results. This data shows multi-agent systems boosting warehouse fulfillment by a whopping 27% and cutting traffic delays in smart cities by as much as 35%. These are tangible, measurable improvements that are only possible when these specialized agents can finally collaborate. So that leaves us with one final, powerful question. We've just walked through the immense technical effort it takes to get AI agents to communicate. But once they can collaborate as seamlessly as we do, what truly complex, world-changing problems will they finally be able to solve for us?